Have you ever tried to actually look inside the black box of a massive machine learning model? It's a lot. Honestly, it's an immense, sometimes completely overwhelming challenge. As these architectures blow up from just a few layers into these staggering multi-dimensional networks, simply understanding what's happening under the hood has become literally one of the hardest problems in modern engineering. So in this explainer, we're going to unpack a brilliant solution to this exact problem, straight out of Apple's research labs.
Okay, let's dive into this. The core question is, how do you visualize a model with thousands of nodes without completely breaking your browser? Because that is the real performance problem developers are facing every single day. You aren't just looking at a few lines of code anymore. You're trying to map out a sprawling, massive network of computations. Traditionally, if you try to load a graph that big into a standard web viewer, it just becomes a tangled, unreadable mess. Or worse, your laptop fan sounds like a jet engine and your browser just straight up freezes.
To solve this, we first have to understand the structure we're dealing with, which is directed acyclic graphs, or DAGs. Now, whether you're a veteran engineer or just dipping your toes into data science, DAGs are the foundation here. Think of them as the ultimate roadmap of an ML model. Directed just means the data flows in a specific direction, and acyclic means there are no loops. The data only moves forward from input to output. Being able to clearly visualize this flow is absolutely crucial if you want to debug or optimize any AI model.
Which brings us to the hero of our explainer today. Meet Mycelium. It's Apple's open-source graph visualization library, engineered specifically to untangle these massive DAGs. It's the result of some really brilliant work from researchers Jochen Gertler, Fred Homan, and Shai Yang. They looked at the exact bottlenecks developers were constantly hitting and built a tool to map out these complex structures visually, intuitively, and most importantly, without all that awful performance lag.
Now, you might expect a totally painful setup process for a tool this powerful, but the developer experience here is practically magical. If you want to visualize a model, you literally just drag and drop an ONNX file directly into the viewer in your browser. That's it. No complicated terminal commands, no giant configuration files to mess with. It just instantly parses the file and renders the graph right in front of you.
And this brilliantly illustrates the whole philosophy behind the project. Mycelium comes with batteries included, meaning it operates as a serious enterprise-grade tool right out of the box. We're talking performance at massive scale, native support for ONNX, which by the way is the open standard for machine learning interoperability, plus it's completely embeddable into other projects and it features a highly customizable UI. You're not just getting some static, boring image, you're getting a dynamic, interactive environment.
So how does this actually translate into performance? How is it handling thousands of nodes without crashing your tab? It uses a super clever three-step approach. Step 1, it leverages scalable vector graphics, or SVG, to keep the rendering crisp and lightweight. Step 2 is really the secret sauce here, hierarchical clustering. Instead of trying to draw every single node at once and overwhelming the system, Mycelium smartly groups complex layers together, so you get the high-level architecture first. Then, for step 3, as you hover over or click on those clusters, rich tooltips reveal the finer details. You smoothly zoom into the complexity only when you actually need to see it.
For the developers watching, the engineering flexibility of this library is just incredible. Under the hood, the graph viewer is written in Svelte, giving it a modern, reactive, and lightning-fast user interface. But, and this is a huge but, it is completely framework agnostic. Because it mounts directly to the DOM, it doesn't matter if your team is building an app in React, Vue, Angular, or just vanilla JavaScript. Mycelium can be seamlessly embedded right into your existing stack.
So the crucial point here is that this isn't just some conceptual toy. Mycelium is totally battle-tested. In fact, it actually powers the graph viewer for Apple's own Talaria system, which is a major internal tool they use for model visualization and optimization. When a massive tech ecosystem relies on a library to visualize its own cutting-edge machine learning models, you know for sure that the tool has proven its ability to handle incredible scale and real-world utility.
We've seen how it solves browser lag through hierarchical clustering, we've seen the seamless ONNX integration, and we've seen its proven track record inside Apple. By taking all the friction out of visualization, Mycelium lets you actually focus on what matters, which is understanding and improving your models. So I want to leave you with one final thought. What are you going to build with Mycelium? The library is open source, it's completely embeddable, and it's literally just waiting for you to drop it into your own machine learning pipelines. Thanks for joining me on this explain.